Hello and welcome back to another session on data structures and algorithms. So in this particular session, I'll be solving a problem based on matrix. So what exactly the question is, if you ask me, the question is very simple. So this particular question is actually repeated in multiple companies, and this is not just asked by product based companies. This question is even asked by service based companies like Infosys, TCS and all of these companies. So what exactly is the question? The question is very simple. You are given a n cross n matrix, something like this. So it's a square matrix. Now all that you need to do is find the transpose of this particular matrix. So I hope you guys already know what exactly a transpose of a matrix means. So in case if you don't know what transpose of a matrix means, let me explain it to you now. So basically, if you take this particular matrix, the transpose of this matrix would look something like this. Now, what has been changed in this particular matrix, if you ask? The size of the matrix remains constant, but something has changed. What is it changed is, if you see the first column in this particular matrix, that is 1, 2, 3, 4, 5. And if you see the first column over here, it is 1, 6, 11, 16, 21. So the first column has changed. So where did this 1, 2, 3, 4, 5 come? The 1, 2, 3, 4, 5 is actually in the first row. So basically I can say that all the rows gets converted into column, or you can say in the other way as well. All the columns gets converted into rows. If you see the column over here, the row over here, 1, 6, 11, 16, 21, that has been converted as 1, 6, 11, 16, 21. So this is what a transpose of a matrix means. So you can observe all the rows over here, all the rows would have got converted to columns over here, or you can say in the other way as well. So I hope you understood what a transpose of a matrix is, and I hope you would have studied all of this in your school days, somewhere in 10th standard or 11th or 12th standard. So I hope this problem is easy for you to solve, and I would actually suggest you to pause the video and solve it by yourself. I hope that you tried writing code for this particular question by yourself. In case if you are not able to arrive at a right solution or right algorithm, nothing to worry about. I will explain you the algorithm over here. So the basic way of doing it, or a very simple way of doing it, if you ask me how can I do this, very simple. All that you need to do is, you have n cross n matrix. So you create another matrix or an empty matrix exactly like this. So once you are done with creating an empty matrix like this, now all that you need to do is convert all the rows to columns and all the columns to rows. Now how can this be done? Very simple. Observe one thing that I am going to do over here. So what I will do is, I will pick the first row over here. So if I pick the first row over here, 1. Now in transpose of matrix, 1 remains in the same place. Next, so I will not consider this one. I will go to the next one and let's see what exactly happens. Now if I go to the next one, that is 6. So what is the index of 6? Let's observe this. So index of 6 is 0, 1. So 0, 1 is the index of 6. Now in your resultant matrix, the 6 will actually go to this particular position, that is 1, 0, and that is where you can see 6 in this particular resultant matrix. So basically I can say that 0, 1 has got converted to 1, 0 in that particular matrix, in the resultant matrix. Next, if I observe this, the 11 is actually present in index 0, 2. So that is what I am mentioning over here. Next, if you see where exactly does it go in the resultant matrix, in the resultant matrix it goes to 2, 0. So over here it was 0, 2, it becomes to 2, 0. So all that's happening over here is only the row and a column gets exchanged with each other. Next, if I go to 16, the index is 0 and 3, and over in the resultant matrix it is nothing but 3, 0. And same way when I go to 4, the actual index is 0 and 4, and in the resultant it is nothing but 4 and 0, and that's what you can see over here. So if you start observing this particular pattern, and that is what I have written, in resultant of 1, 0, what I have is AR of 0, 1, and that is what I have written in the complete thing for the first row. So basically, if I start my row value as I, if I point the row as I and the column as j, so basically what I see over here is, I will consider this particular row, that is 0, it remains constant. So that's what I had shown over here, the I is 0. Next, the value of j starts from 1 and goes all the way till last index. So that's what I have written over here, it starts from 1 and goes all the way till the last index. Now in this I want you to observe one thing. Now all the rows over here would become column over here and all the columns over here would become row over here. That's the only thing that has changed. So basically all that you need to do is you need to say result of ji is equal to array of ij. That's all you have to do. So how can I do this? If you ask, I have to do this for all the elements present in this particular matrix. Now if I have to do for all the elements present in this matrix, definitely I need to traverse this matrix completely. So how would I do that? Very simple. One single statement I know very well is result of ji is equal to ar of ij. That is what I will write over here. Now this particular operation I should actually do for all the elements in the first row. So if I have to do for all the elements, then definitely I need to start the value of j from 0. In this particular example, j, in the place of 0, it didn't do any changes. But still I would consider 0 because it is 0, 0 remains in 0, 0 itself. So I will consider that as well, and the j value starts from 0 and it should go all the way to the last index. So how can I traverse? Just all that I need to do is just make use of a simple for loop. So I will write a simple for loop where for j value starts from 0 and goes all the way to the last index. Now how can I write the last index? Very simple. If I say the length of the matrix, it will give the number of rows. The number of rows is how much? 5. 5, but what I need over here is 4. So how can I get that? Length minus 1. So basically I will write the value of I starts from 0 and goes till the last index. While writing code, I will adjust it accordingly. Now this particular thing, whatever I have done, this is done for whenever the value of I is 0. Now the same thing has to be repeated when the value of I is 1. Same thing has to be repeated when the value of I is 2. Same thing has to be repeated when the value of I is 3. And same thing has to be repeated when the value of I is 4. So basically this particular operation I should not only do for 0th row, I need to do for all the rows. So if I have to do for all the rows, then definitely I need to start repeating this operation again and again and again for all the rows. So how do I do that? Very simple. Since I am repeating this again and again, I need to put this whole thing inside another loop. Now how do I do that? Simple. From where does the row value start? It starts from 0. Until where does it go? It goes till 4. So I will write one more for loop. So I will write for I is equal to 0 and it goes till the length of matrix or length of array. So if you observe this particular for loops, it is one for loop within another for loop. And what exactly is happening over here, if you see, it's nothing but traversing the complete matrix or a complete two-dimensional array. And this code you would have studied at the starting classes of the language fundamentals whenever you study two-dimensional array or two-dimensional list. So I hope this logic is completely clear to you guys, and if you just write this much, you will be successfully able to convert this particular matrix into this particular matrix. So I hope the algorithm is completely clear to you guys. Now let's go and write the code for this particular algorithm. Now let's write the code for this particular algorithm. So I will take you to my editor. So if I take you to the Eclipse, over here you can clearly see the I have taken the same example whichever I had shown you guys. So what I would like to do is, over here I have called one function or a method named as transpose, and I am passing this particular array over here. Now I need to write the logic over here, but before I write the logic, I would like to print that particular matrix. So to print the matrix, one thing that you can do is you can write the code over here itself, but I would not like to write the code over here. Rather, what I would like to do is, I would like to write a separate method for that. So what I will do is, I will write one method over here. So I will say static, and this method should not return anything, so I will write void, and I will say print matrix. And this method will actually accept one matrix, so I will just name it as AR itself. So it is an integer type of two-dimensional array, so I will put 2 square brackets and I will name it as AR, and I will come inside this. So over here I need to actually print that particular matrix. Now how do I print the matrix? If I have to print, definitely I need to traverse this complete matrix. Now if I have to traverse this complete matrix or a complete two-dimensional array, you have already studied that I need to make use of 2 for loops. And I even know that this particular matrix is a square matrix. So the number of rows and the columns remain same. So what I would like to do is, I'll go and write one for loop over here. For the value of I starts from 0 and goes till the last index. So I would say int I is equal to 0, I is less than AR dot length. Next, I plus plus. Next, this will help me to traverse the rows. I need to traverse the columns as well. So in every row I need to traverse the column. So what I'll do, I will write one more for loop. So I'll say for int j is equal to 0, j is less than AR dot length, AR dot length, next j plus plus. So since it is a square matrix, I am using AR dot length over here and AR dot length over here because the number of rows and columns would remain same. Next, what I would like to do inside this, very simple, I would like to say system.out.print. System.out.print. I don't want println because println will take the element to the next line after, take the cursor to the next line after printing the element. So I want the cursor to be on the same line. So what I'll do is I'll say print, and after that I'll print the element, that is AR of ij. I and j. Next, after printing, I just want to leave one space, so I'll concatenate one space after this. Great. Now this particular for loop, the inner for loop, will take care of printing the complete row. Once it's done with printing the complete row, the condition would definitely fail and it will come out of this inner for loop. Once it comes out of inner for loop, it will again go increase the value of I, check the condition, come in. Now it starts printing the next row. But before printing the next row, I want to actually take the cursor to the next line. Because I am saying print, the cursor remains on the same line. So I will say system.out.println. So I hope these things you would have already studied in pattern programming and all of those things. So now I would like to save this, and I would not like to call transpose. Rather, what I would like to do is I will just comment this and call print matrix. I'll say print matrix, and I'll pass AR. Let's print and see if we are getting the expected output or not. What I exactly want is I just want this matrix to be printed. So if I just execute this particular program, I have executed this particular program, and you can clearly see 1, 2, 3, 4, 5 in the columns you can see, or in the row wise if you see it's 1, 6, 11, 16, 21, 2, 7, 12, 17, 22 and goes on like this. So I hope you know that it's printing it properly. Now all that I would like to do is just write the code for transpose. So what I'll do is I'll come over here. Yes. Now print matrix, I would like to print this matrix before calling transpose. So I'll take this line above. Yeah, I will uncomment this line. Yes. Next, let's go to transpose of the matrix, and over there let's see what is the code that we need to write. So over here is where we need to write our major logic. So what is that logic? This is that particular logic. So let's write this. So basically I just have to write two for loops and just do some arrangements of copying all the elements from the row to the column. But how, before I do that, you can clearly see that I am creating a new array over here and I am copying the elements to the new array or a new 2-dimensional array. So first let's create a new 2-dimensional array. So how do I create a new array? It's very simple. I need to say new, and after that 2 square brackets. Before 2 square brackets I need to say int and then square brackets, because I need to say what type of array I am creating. So it's integer type of array and I have put the square brackets. Now inside this square brackets I need to say how many rows will be there, and inside this I need to say how many columns will be there. Now how do I say this? Very simple. You know very well how many rows are there. And how can you get the number of rows? Very simple. If you just say ar.length, you will get the number of rows. So I'll say ar.length inside that. So this is the number of rows, and you know the number of columns is also same as number of rows. So I'll just copy this and paste it in this square bracket as well. So this would create a new array of the same size as AR. Now what I need to do is I just have to give a reference to this. I will name it as res. And since this is of integer type array, I need to say int. And since it's 2-dimensional array, 2 square brackets. Yes. Great. Yes. One space. Yeah. Great. So now I am successful in creating a new array. Now what I need to do is I just have to write this logic. So let me start writing this logic. So I'll start with for loop. So I'll say for. You can see clearly the value of I starts from 0 and goes all to the last index. So basically if you observe, whatever code I wrote for print matrix, that is nothing but traversing the complete array. The exact same code has to be written over here as well, but only instead of printing I need to do something else. So let me write over here, for int I is equal to 0, I is less than ar dot length. It will go till the last index, so the last row, next I plus plus. I will come inside. Next, inside this, what I need to do is I need to traverse all the element in a particular row. So I need to traverse all the columns. So I'll say for int j is equal to 0, j is less than ar dot length, j plus plus. You can change this to less than, comma to less than. Great. Now inside this is where the magic is. So what is that I need to do is I need to say ar of ij. ar of ij. Now whatever element is there in ar of ij, I points to row, j points to column. Now I need to just swap this and put it in res of ji. So how do I do that? Res of ji. So res of ji. So ji. So you can clearly see whatever was there in row over here comes to column over here, and whatever is there in column over here comes to row over here. That is all I have to do. So this will take care of transpose. Now let's go and check whether it is actually printing the expected output or not. So what I'd like to do is I would like to go to the main method. Yes. Now over here I would like to print this matrix once again. So I'll just duplicate this line and get it down. Now before printing the matrix again, so I will put one more line. I will just press enter. I'd like to write system.out.println, just I am leaving one space extra, that's it. There is no logic behind this system.out.println, and I hope you guys already know all of those things. Next, basically I am created an array, then I am printing the matrix, then I am transposing it, and over here I am writing AR, but AR is not the matrix that I transposed. If you want to see, we will just execute and see. So if I execute this particular program, you can clearly see on top and in bottom you are seeing the same. Why you are seeing the same matrix? Because your result actually lies in another array, but you are printing the same array. So let's do the necessary changes. So I will just close this and let's go back to the transpose. So if you observe in this particular transpose, the result is there in res. Now my duty is to return this res to the main method. How do I do that? I will say return res. Now you know the this is not matching because over here I told void, it means I am not returning anything, but you can say I am returning an array. So if I am returning an array, definitely I need to put 2 square brackets. So I will put 2 square brackets over here instead of void. I don't need a space in between. Yeah. Now this particular array is of what type? It's of integer type. So I need to say int as well. So I have been successful in saying the return type, and I have returned the value as well. Now what I need to do is I need to go to the main method. So in the main method, this whenever you call this transpose is returning you something. So let's collect that. So I will collect that inside a result. I will say result. Okay, res, fine. So this res is of type what? It's of type integer type array. What type of array? 2-dimension array. So since it's of type integer, so I will write int. Since it's 2-dimension array, 2 square brackets. 1 more square bracket. Great. Now over here I don't have to print AR, rather I need to print res, so I will pass res over here. That's all. Now the code is successful. Now all that we need to do is just let's execute and see if we are getting the expected output. So if I execute this particular thing, you can clearly see 1, 2, 3, 4, 5, whatever was the column has become row. 6, 7, 8, 9, 10, whichever was the second column has become second row, and the same thing has been happened in all the other cases. So I hope the code is completely clear to you guys. Now I want a small change to be done. And if you ask me what is that change I have to do, I just want to see, I want you guys to observe what is the time complexity of this particular algorithm. So if you see, there are n rows. So what is the time complexity? You are basically traversing all the elements. So if there are n rows, how many elements will be there? N square, because you can clearly see I have written 1, 2, 3, 4, 5, 6 till 25. So there are 25 elements. So there are 5 rows and 25 elements. So what is the time complexity? since I am traversing all of this, the time complexity is nothing but n square. Now if I ask you what is the space complexity, now if you observe this, the space complexity of this is also n square because I am creating a new array of the same size. Now I would like you to optimize this code in such a way that the space complexity is reduced to n square to constant, that is big O of n. Now how can, big O of 1, not n. So how can this be done? Very simple. This can be done without creating a new array. So now I want you guys to think about this and write a code to actually create a transpose of a matrix without creating a new array. Now, is that really possible? Yes, it's really possible. I would like you to do this particular problem by yourself. In case if you are not able to do not worry, watch the next video. Over there I will explain you how to do that without creating a new array.
If you have enjoyed this video and would not like to miss any of our videos, hit on the subscribe button and click the bell icon.